All right, so this is today's classwork. You're going to work on 4 different problems. So you're going to get this worksheet, and just like yesterday in class, you're going to draw all these out, all the steps out, and then put the reasoning on the side over here. So I'm going to go here to where it says virtual help, and it's going to open up that problem here. You could access this as well if you want in Google Classroom, so that way you can work on this and follow along. But basically, I'm going to show it to you here, and what your goal is to transfer the steps here. So if you already know how to do the steps, you don't need to watch the video. But if you need help in understanding what is the next step, I'm going to show it to you here, and based on what you see here, I want you to apply it and copy the steps here. So anytime you're solving a problem like this, your goal is to solve for x. And notice we have x's on both sides. We have positive x's over here, a total of 6, and then here we have 2 negative x's. You always want to look at the side that has the least amount of x's. And clearly when you're comparing positive x's and negative x's are always less value than positive x's. So that means I'm going to start off on this side and eliminate these x's. So since these are 2 negative x's, the only way to eliminate those 2 is to do the opposite, which is to put 2 positives. You can see here when I put 2 positives, it made the balance uneven. It's not balanced anymore. So since I added 2 x's here, according to the addition property of equality, you're going to have to add 2 x's on the other side in order for it to balance out again, and you can clearly see it does balance out. My next step is to combine the 0 pairs here. So I'm going to simplify by combining 0 pairs. Then I check the other side. There are no 0 pairs, so my second step is done. Next, I have all my x's on one side. And again, I'm still trying to figure out what's the value of 1x. So to do that, I'm going to have to eliminate these 1's that are on the same side as my x's. So since I have 8 positive 1's, I'm going to have to create 0 pairs, so I have to put 8 negatives. So the opposite of 8 positives is 8 negatives, so I'm going to put that next. So you can see here I put 8 negatives. It's not balanced anymore, which means I have to do the exact same thing on the other side. So I'm going to clone this, put this on the other side, and it'll balance out because according to subtraction property of equality, if you take away 8 on one side, I got to take away 8 on the other side as well for it to balance out. So properties of equality means to keep your scale balanced, whatever you do on one side, make sure you do the exact same thing on the other side. Next step I'm going to do is to combine my 0 pairs. So you can see here I combine my 0 pairs, and I'm left with 2, 4, 6, 8 x's on the left and 8 1's on the right. We want the value of 1x, so my next step here is to use the division property of equality to figure out how many x's matches up with how many 1's. So we're going to split it up. Since we have 8 x's, I'm going to create 8 groups over here and 8 groups over here. So you can see here, I split it up into 8 groups here, split it up into 8 groups here. That's the division property of equality, again, when you split it up. And that allows me to see that each x matches up with one of the 1's. Therefore, you can see my solution. That means each x is worth 1 unit. All right, here we got problem number 2. So you're going to write your equation here, and then we're going to solve this again using the algebra tiles on this website here. Don't forget, you can click here if you want to work alongside with me. So here I can see I have 4 x's here, and 4 y's here and 2 y's here. Anytime you have variables on both sides, you want to eliminate the variables that has the least amount. So we have 2 y's here, that's less than 4 y's. So I'm going to eliminate these y's. That's how I know where to start. And to get rid of these 2 y's, I always got to put the opposite. So opposite of 2 positive y's is 2 negative y's. You can see here that I put 2 negative y's here. The equation is not balanced anymore. So if I take away 2y on one side, I got to take away 2y on this side. And you can see it balances out again. So subtraction property of equality, always do the same thing to both sides if you want to keep your scale balanced. You can see here my next step was to combine my 0 pairs. So I combine the 0 pairs together. I'm left with 2 y's over here and only 6 1's on this side. And then we also have 8 1's on the same side over here. So my next step is to isolate the y. In order to isolate the y's, that means I got to get rid of these 1's. To get rid of 8 positive 1's, you got to create 0 pairs. So always do the opposite of what you have. So opposite of 8 1's is 8 negatives. So you can see here, I put 8 negatives on this side and 8 negatives on this side. That allows me to balance the equation. And again, since I subtracted to both sides, this is subtraction property of equality. Next, you can see I combine my 0 pairs. I'm left with 2y here and 2 negatives here. So all I got to do to figure out the value of 1y is to use the division property of equality by creating 2 groups. So when you're left with a whole bunch of y's on one side, you just split them up. Since we have 2 y's, that means we have 2 groups here, which tells me to create 2 groups on this side, which is easy because I just got to split these up. And now we can see that each y matches up with a -1. And if I were to delete this y and delete one of the negatives, you can see my equation is balanced because we found the correct value or solution, which is y equals -1. All right, so now we are on problem number 3. Notice we have x's on both sides. In order to solve for x, always eliminate the x's that has the lowest amount. So since we only have 2 x's here, I'm going to eliminate those. And the way we do that is you got to always create the opposite. So opposite of 2 positives is 2 negatives. You can see by doing that, it's not balanced anymore. So I always have to apply the same thing I did to one side to the other side to bring it back to balance. And you can see that that's what I did there. Subtraction property of equality. Took away 2x to both sides. Next, I combine my 0 pairs. And you can see here, we have 4 x's here and 2, 4, 6, 8, 10, 12 ones on the left side. The way we solve for x, whenever we have a whole bunch of x's, is to use the division property of equality to split it up into equal groups. Since I have 4 x's here, that means I'm going to create 4 equal groups. So I'm just going to split it up into 4 equal groups. And if I do 4 groups on this side, I got to do 4 groups on this side as well. So you can see here, 4 groups here, and I created 4 groups here. Each x matches up with 3 ones. So it's important to remember, when you do create your groups, make sure they have the same amount in each group. And again, since we know that we have 4 groups here and 4 groups here, I can easily see each x matches up with 3 ones, which allows me to see, again, that my solution is x is equal to 3. And then we have the last problem, number 4. It looks a little bit different because we have a whole bunch of halves on this side and this side, but it's still the exact same idea. Look at the side that has the lower amount of x's. There's 4 halves here, 3 halves here. Therefore, I'm going to get rid of these 3 halves by putting the opposite, which would be 3 of those, but at negative values. And before I actually solve it, one thing to point out is if you're struggling on how to write this equation, this is how you would do it. So you can see here, this is x over 2. So I write down x over 2. How many of these do we have? We have 4 of them. So that means I have 4 halves x. So I'll write it like that, 4 halves x. And you'll notice 4 divided by 2 is 2. And remember, 2 of these together make a whole amount. 2 of these make a whole amount. So essentially, this is just really 2x. But I'm just going to leave it like that for now. There's 4 halves. Then I have -6, so I'll put that there. Equals, and what do we have on the other side? 1, 2, 3 halves. 3 of those halves. So you can see here, 3 of the halves. So 3 halves of the x minus 8 of those ones. So 3 halves, 3 halves, 4 halves, 4 halves. So going back to solving the equation, eliminate the one that has the lower amount. This is less, so I'm going to eliminate those by making 3 copies of those, but making it the opposite. And then I make sure I do that to the other side, so that way it's balanced. Next, you can see I combine my 0 pairs. I'm left with 1/2 x over here, 6 negatives and 8 negatives. So since I isolated my variable, that means I got to get rid of these ones by introducing the opposite of those, which is 6 positives. So you can see I added 6 positives here. And to keep the equation balanced, I also added 6 positives here. Addition property of equality. Next, I'm just going to combine my 0 pairs. So I put these together and these together. And now I can see I have 1/2 x and 2 negatives here. Now remember, when you're left with a half, you don't want the value of a 1/2 x. You want 1x. So you have to recall, when you take a whole x and split it in half, that's how you get the halves. So that lets us know we need 2 of these to make a whole amount, which means I have to multiply this. So I have to double it. And since I double this side, notice that it's not balanced anymore. I have to double this side as well. So I'm going to double this one. And you can see it balances the equation. This is multiplication property because we made 2 copies on this side and 2 copies on this side. So now we can clearly see these 2 make a whole amount. So if I merge these, so that's 1x is equal to -4.